Hello and welcome back to Math with Mrs. Becker. Today in Algebra 2, we are going to look at transforming polynomial functions. Now the cool part about this is we have already done lots of transformations in this course so far this year. We have transformed points, lines, quadratics, so you have seen all of these different rules, okay? But just in case you need to refer back to the rules. I did include a slide, just kind of as a little cheat sheet as we go through this. But one thing that you should notice is that the rules are the same as when we looked at transformations prior in this course, okay? So if we're starting off with a function, if I have f of x equals x cubed minus 6, they want us to now find g of x. This tells me to keep the original function the same, just minus 2 to the end of it. If you keep the original function the same, add or subtract to the end, that is called a vertical translation or slide. If you're adding, it's going up. Since we are subtracting, we are moving down 2. So that's what we would be doing with this graph, taking it and sliding it down the y-axis 2 units. So here I will rewrite the f of x function. Now I will minus 2 to the end of it. So what I need to do now is just combine like terms. Negative 6 and a negative 2 can be combined to make negative 8. Here is my new rule. This is what we did with the original function. Okay. Now this one's a little bit tougher. Remember when you add or subtract in parentheses, that's a horizontal slide. Horizontal lines run left and right. So if we are doing a horizontal slide or translation or a shift, it has to be either going to the left or the right. When I look back at my little cheat sheet, notice that it's x minus the value. Well, because this is a plus, we need to realize that this is really x minus a negative 1. So the value here is negative. So we are going to the left 1 unit. That's what we're doing to the graph. We're taking the whole thing, sliding it left 1. When you have your change in parentheses, what this means is you go to the original function where the x was, I need to change it to x minus 1. So it would look like this, x plus 1. X plus 1 cubed minus 6. This x plus 1 replaced the x. Now I need to expand it. X plus 1 to the power of 3 means that I have x plus 1 3 times. And then don't forget, we still have this minus 6 at the end. You can only multiply 2 things together at a time. So if I multiply these 2 terms, I would leave this x plus 1 out. If I FOIL it, x times x, this is x squared. X times 1, this is 1x. 1 times x gives me 1x. 1 times 1 gives me 1. I can combine the middle 2 terms. 1x and 1x gives me 2x. Now I need to distribute. So an x goes to all of these terms. It does not apply to the negative 6 because when you distribute, it only goes to whatever's inside of the parentheses. So x squared becomes x cubed. 2x, when I give it another x, it's 2x squared. 1, when I give it an x, it becomes 1x. Now what I need to do is multiply everything by 1. 1 times x squared is 1x squared. 1 times 2x is 2x. 1 times 1 is 1. Don't forget we have a minus 6 at the end. Now to find our new rule, our new equation, combine any like terms, have it in the right order. So x cubed would go first. 2x squared and 1x squared makes 3x squared. 1x and 2x makes 3x. 1 and a negative 6 makes negative 5. Here's the new rule. What we did is we took that graph and we slid it to the left 1. Okay, let's look at another one. Again, we're working with the same f of x, x to the power of 3 minus 6. Again, if you're adding or subtracting in parentheses, that's a horizontal slide, shift, or translation. Horizontal lines slide left and right. The formula says x minus h. That means that this is really x minus a negative 3. Because this would be a negative value, we are sliding to the left 3. Okay, that's what type of transformation occurred. Now to write the rule, I have to change the x's to whatever's in the parentheses. So this becomes x plus 3 cubed minus 6. X plus 3 cubed means I have x plus 3 3 times. You can only multiply two things together at a time. So if I multiply these two, x times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. So I can combine these like terms. So I'd have x squared, 3x and 3x makes 6x plus 9. Don't forget I have that minus 6. Now I have to distribute. I'm adding one more x to each term in the parentheses. That makes it x cubed plus 6x squared plus 9x. Now I'm multiplying everything that's in the parentheses by a 3. That makes it 3x squared plus 18x plus 27. Don't forget we have a minus 6. Now to write your final rule, combine like terms and put it in the correct order. So x cubed comes first. This term has 2 x's. This term has 2 x's. 6x squared plus 3x squared makes 9x squared. This term has an x and this term has an x. 9x and 18x makes 27x. 27 and a negative 6 make 21. Here is the new rule. That's what this function would look like if you slid it to the left 3 units. Okay, one more horizontal or vertical slide. This time you're subtracting after the function. If you are subtracting or adding after the function, that is a vertical slide or shift or translation. Vertical lines run up and down. So this has to be either going up or down. This is a minus 5. So we go down 5. The way you find the rule, rewrite the original function. X cubed minus 6. Now you minus 5 to the end. I can combine those two like terms. So x cubed minus 11 is the new rule, the transformation that occurred. You took your original polynomial function and you slid it down 5 units. All right, next ones. These are reflections, okay? So reminder, if you are reflecting across the x, the negative goes up front and you distribute it to everything. If you reflect across the y, it's going only to the x. So all of the x's in the problem will need to change to a negative x. Okay, so if I am going to first take this function, this is my f of x. We want to perform each transformation. They want us to reflect this across the x. If you reflect across the x, the negative goes out front. What that means when the negative is out front, that you have to distribute the negative into every single term. This becomes negative x cubed minus 5x squared plus 8x minus 1. There's your new rule. If you are reflecting across the y-axis, I take every single x in the problem and I have to change it to a negative. Now we have to go and figure out, like using our exponents, this negative will occur 3 times. So negative times a negative would be a positive, but the third negative would make this a negative x cubed. When I put the exponent here, negative times a negative, this will remain a positive 5x squared. Negative 8 times negative x is a positive 8x plus 1. Here's what the equation would look like if you flipped it side by side over the y-axis. One more to make sure we've got it. If I am starting off with this polynomial function, if I want to reflect it across the x, the negative goes out front. When the negative goes out front, it has to be applied to every single term. So now we'd have negative x cubed plus 2x squared plus x minus 2. So what happens when you reflect across the x is the sign changes for every single term in the original function. When you reflect across the y, only the x terms change. And to change them, you change it into a negative x. Now when I have this power of 3 on a negative, negative times a negative is a positive, so the third negative would keep this in negative x cubed. Here, negative x times negative x would be a positive x squared times negative 2, negative 2x squared. Negative times a negative is a positive x plus 2. So there are two examples of how we can do reflections. Next, we have size changes. When you are multiplying out front, that means that you will be distributing. When it's out front, it's vertical. So we have a vertical. If the number is bigger than 1, it is called a stretch. If the number is less than 1, it's called a compression or a shrink. This is 1/2. 1/2 is less than 1, so we have a vertical compression by a factor of 1/2. The way to find the rule is that 1/2 is out front of the original, which is 2x to the power of 4 minus 6x squared plus 1. I go ahead and I distribute. 1/2 of 2x to the power of 4 is 1x to the power of 4, minus 1/2 of 6x squared is 3x squared, plus sign. 1/2 times 1 is 1/2. Here's your new rule. What we did is we took the shape up and down and we compressed it, so we made it shorter. When you have multiplication inside parentheses, it's horizontal. So to see if it's a horizontal stretch or compression, remember when you're multiplying to the x, this 1 means you take the reciprocal, okay? If I take the reciprocal of 1/3, if I flip 1/3 over, it's 3/1. 3 is bigger than 1, so this is a horizontal stretch. Now to find the new rule, whatever's in parentheses, we keep it and we replace all of the x's with 1/3x. So 2 times 1/3x to the power of 4 minus 6 times 1/3x to the power of 2 plus 1. Order of operations, we have to do the exponents first. Remember, when you have an exponent, it has to go to everything. So 1 to the power of 4, 1 times 1 times 1 times 1 is 1. 3 to the power of 4, 3 times 3 times 3 times 3 is 81. X also gets a power of 4, minus 6. 1 to the power of 2 is 1. 3 to the power of 2 is 9. X also gets a power of 2 plus 1. Now what we have to do is realize that this 2 is a fraction. It's like 2/1. When you multiply fractions, it's top times top, bottom times bottom. So this would become 2/81, x to the power of 4. Now when I multiply this, I end up with 6/9. Well, I can divide both top and bottom by 3. So this would reduce to 2/3 x squared plus 1. Again, when the change is inside of parentheses, you replace the x with whatever was inside the parentheses. This is a horizontal stretch because when you're multiplying to just the x in parentheses, to see if it's a stretch or a compression, you do the reciprocal of the number. Okay, here is another one. If I have a number being multiplied out front, if it's out front, not in parentheses, it's vertical. Vertical, you keep the number how it is. This is 1/4. 1/4 is smaller than 1, so this is a vertical compression, also sometimes called a vertical shrink. The way that you find the new rule, I would take that 1/4, put it out front of the entire original function. 16x to the power of 4 minus 24x squared plus 4. So 1/4 of 16x to the power of 4 is 4x to the power of 4, minus 1/4 of 24x squared is 6x squared, plus sign. 1/4 of 4 is 1. So those last three examples were stretches and compressions. Now what can happen? They might have you do more than one transformation per problem. So if we're starting with 6x to the power of 3 minus 3, they want us to go ahead and follow these rules. You just go one step at a time in the order that they're asking us. So step 1, compress it vertically by a factor of 1/3. To do a vertical compression, that's where you take whatever the factor is and you distribute that out front. So 1/3 of 6x cubed is 2x cubed, minus 1/3 of 3 is 1. Now to shift 2 units to the right, that change is inside of the parentheses. It's x minus whatever direction you're going. We're going 2 units to the right. The right is a positive 2, so when I plug a positive 2 in here, this remains a minus. Order of operations, I have to do the exponent first. So x minus 2, x minus 2, x minus 2. I can only multiply 2 things together at a time, so I'm leaving this x minus 2. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is a positive 4. So x squared, negative 2x is negative 4x plus 4. Now I need to distribute an x to everything. X cubed minus 4x squared plus 4x. Now I distribute a negative 2. This is negative 2x squared. Negative 2 times negative 4 is a positive 8x. Negative 2 times positive 4 is a negative 8. Keep in mind, all we're doing at this point is this. We're just doing this power of 3. So I still have a 2 out front. Combine like terms. X cubed, negative 4x squared, and a negative 2x squared is negative 6x squared. 4x plus 8x makes 12x minus 8. And then again, don't forget, where am I? There we go. We have it right here. So I have a 2. This is what x minus 2 cubed is equal to. Don't forget, you still have a minus 1 out front. So now, again, we have to keep with order of operations. So I distribute the 2 to everything. 2x cubed minus 12x squared plus 24x minus 16. This minus 1 did not go with the 2 because it wasn't in parentheses. Combine these 2, that is your new rule. 2x cubed minus 12x squared plus 24x. Negative 16 minus 1 more is negative 17. So we took our original shape, we took it top and bottom, and we made it shorter. We did a vertical compression. Then we took the whole thing and we shifted it to the right 2. When that happened, it would change this equation to this. Kind of cool stuff. Okay, here is another one. Write a function, so we're taking the same one. What you have to do is just go in order. If I want to reflect across the y-axis, that means I'm changing all of the x's. So the x's become a negative x. Well, negative x times negative x times negative x is negative x cubed. So that's what this would end up being. 6 times negative x cubed, this is now negative 6x cubed minus 3. Now to shift it down 2, that is a vertical slide. Okay, if I'm doing a vertical slide, you just go ahead, keep the function the way it is. If I want to go down 2, I minus 2 to the end. So I go ahead and combine the like terms. Our new rule is negative 6x cubed minus 5. Okay, so the last 2 examples were what do you do if they want you to do more than one thing. For time purposes, I'm going to go ahead and skip this one because it is the same equation. You're just doing 2 things. You would reflect it across the x, so you distribute a negative, then move this to the left 4, so you'd be doing one where inside of the parentheses, x minus, if you're going to the left, it would be a minus 4, so you would change all of the x's to an x plus 4. Okay, but I don't want this video to go more than 20 minutes, so we're just going to skip that one since we've already done 2. The last thing, the number of skateboards sold per month can be modeled by this function. This is the number of skateboards sold per month. If they want us to apply this transformation, notice it says keep this function the way it is, just add 20. So our new function would be everything the same except for the 130 plus 20 is now 150. And what does it mean? I added 20. So I sold 20 more skateboards during the month since May. So this is how many per month. After May, you started selling 20 more skateboards per month. Here is another one. The number of videos sold per month can be modeled by this. This is a vertical slide because you're keeping the original function the same. You're just subtracting 15 to the end of it. In order to simplify it, we just have to combine the like terms. So your new function every term is going to be the same except for the last term, 125 minus 15. That's going to be 110. This is the number of videos sold per month. Because it's a minus 15, what's happening is you're selling about 15 less videos per month. So that is 6.8 transformations of polynomial functions. The assignment is a worksheet. I'll talk to you soon.